going to be, if f of x equals sine x, then f prime of x is equal to cosine of x. And we're going to show that using the limit definition of the derivative. So our original function is sine x. And there's a few preliminary pieces of information that are going to be useful before we calculate our limit definition. So, number one, I'll remind you that the limit as theta goes to 0 of sine of theta over theta is equal to 1. We've been working with that one quite a bit. There's a second limit rule that we haven't specifically worked with, but it's similar to the sine of theta over theta equals 1. And this limit rule is that cosine of theta minus 1 over theta is equal to 0. And the third one, this is where all of your hard work in trig comes in. The third one is a trig identity, that the sine of a plus b, does anybody remember what the sine of a plus b is equal to?
Sine A plus cosine.
Sine A cosine B plus cosine B sine A.
Yeah.
Yeah, all right. All right, so we've got it. Sine A cosine of b plus cosine of a times the sine of b. All right, so these three pieces of information are going to be useful in calculating this limit definition. All right, so f prime of x is equal to the limit as h goes to 0 of f of x plus h minus f of x all over h.
So there's, I have a question. So that doesn't have to do with limit?
No, this last one is pre-limit stuff. This is just a fact for all angles A and B.
Okay.
All right, so pieces that we want to fill in. Well, I'll write down the limit as h goes to 0. F of x plus h. Our function is sine x. Everywhere I see an x, I'm going to replace that with x plus h. So I have the sine of x plus h minus sine of x all over h. Now, at this point, without any of this information over here, it seems like I might be a bit stuck. There's not much I can do with this. And so really the only thing I can do is look at this sine of x plus h. Two angles are added together. So I can use my third rule here, my trig identity. And so I'm going to write this numerator as the sine of x plus h. My x is my a and my h is my b. So I've got sine of x times the cosine of h plus cosine of x times the sine of h minus sine x all divided by h. All right, so we've used number 3 here. Now, the other two pieces of knowledge up here, the one I like best is sine of theta over theta, the limit is theta goes to 0 is equal to 1. So over here, I've got an h in the denominator, so I want to find the sine of the same angle in the top as is in the bottom. So I'm going to look at this term right here, and I'm going to pull that toward the front. So I'm going to rewrite this as the limit as h goes to 0 of cosine x times the sine of h plus sine of x times cosine of h minus sine x all divided by h. Now the sine h over h, if I want to get that part by itself, I can break this up into two separate fractions here. I can write this as limit as h goes to 0 of cosine x times sine of h over h plus sine of x cosine of h minus sine x over h. All right, any thoughts on how we might simplify this anymore? Anything else that we might do? Ben?
In the second half of that equation, you can pull out a sine x, and end up with cosine h, sine x times cosine h minus 1. And then that'll cancel from the bottom.
Okay, so hold that sine x like that.
Yep.
Okay.
In the first one, can we do the number 1 and have cosine x times 1? Or can we not pull that out?
Okay, so that's a good question. I mean, one of our limit rules does say that if we have two functions that are added together, we can distribute that limit symbol to both of them. So let's at least do that, and then we can work with that cosine of x times sine of h over h, and then we also plus the limit as h goes to 0 of sine of x times cosine of h minus 1 over h. And so, Jennifer, your thought was, can we kind of ignore the cosine of h and look at sine h over h? And the answer to that is sort of. And so the real answer is yes, we can, because in the eyes of this limit has to do with h approaching 0, and cosine of x is completely unrelated to the h's. There's nothing changing about cosine of x. So in the eyes of this limit, cosine of x is a constant. And so we can pull cosine of x in front of our limit symbol. So we have cosine of x times the limit as h goes to 0 of sine of h over h. And once we have it written like this, then yes, this limit is equal to 1. Now, the second one, that sine x plays the same role, plays a constant role, and here sine of x is completely unrelated to h, and so we can pull that sine x out in front. So we've got sine of x times the limit as h goes to 0 of cosine of h minus 1 over h.
Last term equals 0.
Yes, so that second one there, the limit is h goes to 0 cosine h minus 1 over h. That guy equals 0. And so what we have here is we end up with cosine of x times 1 plus sine of x times 0. So 0 times anything is 0, and 1 times anything is that anything. So we end up with cosine of x.